frustrates me.
know, me
It just
too.
frustrates me so much.
It'll, by the, I don't know. in the
By
next couple-
week 10, we're gonna have it all figured out.
Yeah, and then next term will be easier for you.
Well,
And us, because I'll be in 243, so
well,
if you use
I
it.
hope, I think I will. I mean, it works well when it works. Like, the kicker is making it work. And I agree, Christine. I think it's gonna be a great,
It's
great
just a
thing.
learning curve, I think.
Yeah, and I hope, the thing is, I hope the learning curve doesn't reset every term. That's what I'm nervous
Well,
about.
you'll know how to present it different, maybe.
Hopefully, yes, I'll definitely know that for sure. That doesn't look very, no, it's not bad.
It's probably the lights.
Yes, it is, absolutely correct. Ooh, mood lighting, yes. All right, so, let's get back into math, please. Yes, let's talk about math and statistics, because we're starting to talk about statistics now, which is, you probably didn't realize that yesterday when we kind of got into this. So, we looked at some data about uninsured people in America. And I think it was Brittany and Amy both brought up a very good point at the very end. The article we had looked at before said the percentage of Americans that lacking health coverage has fallen. But the data shows the number of Americans going up from the period of time of 1992 to 2000. I agree that's an apples-oranges statement, yes? Because one's a percentage, one's the number. We can analyze the percentage fairly simply once we have the correct number. Because all we got to do is take that number and do what? Well, good, divided by 310 million, which gives it a percent.
Yeah.
No, but you got it though, Krista. It gives it a percentage out of 100. Exactly. That's one of the reasons I like that quiz from last week about the interpretation of percentages, was it just got you thinking again about the idea of what a percentage means. It's a big part of this course, being able to know what a percentage means in what application. So that's this. Yay. Now, what I did next was get this into what's called a scatter plot. And I think we made peace with this. Some of you had said you have seen them before. By the end of the course, your last project teaches you how to actually make these things in Excel. And that's one of those things I noticed a lot of students. How many of you guys have taken CIS 120 or CIS 131? You see, that's funny. That's 5 people in the class. It used to be the entire class raised their hand because you used to have to take CIS 120 and CIS 131. And about 5 years ago, they took that requirement away. And that makes me sad. That makes me sad because I think as math students, you should have an ability to be able to create these kind of graphs using computer technology. Yeah, the TIs are great, and they're great for in class, but in the real world, if you want to put this data in a place where you can actually see it, we're going to use at least Excel, if not other things. So we'll learn that in project number 4, which is not due till week 10, plenty of time. So anyway, scatter plot is nice. You guys said you liked it better because it gave you a visual, which I thought was great. What else is kind of cool about, here's a bigger look at it. What else is cool about this scatter plot that you don't get from a simple table? What I'm going to do is I'm going to kill this, and I'm going to drag it down a little bit lower. See how that centers on the board? Nope, not quite. What's cool about the scatter plot versus simply looking at a table?
You can actually see it increasing.
Oh, Jessica, you can see it increasing. You can see it. See, the thing about looking at the numbers, which is great, is you might catch the increase. You might. You probably would if you looked at it long enough. Sorry about my squeaky today. I drank a lot of water in the pool. You probably would if you looked at it and you crossed your eyes long enough at it. So you can definitely see the increase without having to think about it too much. That's great. Awesome. So the visualness, the increase jumps out at us. Fantastic. Why else is it great? Why else is it? You guys mentioned this last time, but you might not remember what you said. Say that again.
Trend.
Chrissy, tell me more.
You can see the trend.
What's the trend?
The trend is that more and more people are not having health insurance.
How many more? Is it a consistent trend? Is it a changing trend? This is a loaded question, FYI. This is a loaded question because either answer, any way you answer is correct. So you just did this. You just said, well, it's changing like this. Exactly. Did anybody say it's not really changing? It's kind of going like that. Anybody think of it? This is a very statistical question, so therefore I don't expect you to have thought of this answer today. How many of you said, oh, it's like an S curve? It's like an S curve. It goes like this, right? Yes, absolutely. And we could actually model that using an S curve. We could. We could. But what I've learned statistically is, I just used the word model. That's a new word. We have to talk about that today. What I've learned statistically is you generally want to go with as simple a trend as you possibly can. And more on that momentarily. So I asked you a loaded question, and I appreciate it, Chrissy. Anybody else? Why is the scatter plot better? What did we do with this yesterday? Once we had it on the board, what did we start doing? Do you remember? We spent a lot of time with this, actually.
Found the ratio.
Oh yeah, we basically forced the slope into it by looking at pairs of points. What did we notice about the slopes after we had analyzed a bunch of the slopes? What did you guys notice? What do you remember noticing about it?
1 million every 1 year?
Mm-hmm. Was it always 1 million every 1 year? Thank you, Ashley.
No, but it averaged out.
Oh, say that again, please.
No, but it averaged out.
One more time, a little bit louder.
No, but it averaged out to that.
Yes, so sometimes it was 1 million per year, sometimes it was 500,000 per year, sometimes it was 1.5 million per year. But that was looking at 2-year increments, right? If we stretched it out to 4-year increments or 6 or 8, it varied, but it didn't vary, I never used those words together before. It didn't vary never mind. I have to get to it didn't change much. It always kind of hovered around 1 million. You went right with 1 million per year, didn't you? And if you guys remember, when we actually looked at the slope from point 1 all the way to point 5 over there, what was that slope? Do you remember? 1.13 million people per year, which is damn close to that 1. So that's what, this goes back to my question, Brittany, Chrissy, to you, is, yeah, it definitely does this, but even when you micro-analyze any pairs of points at all, it's fairly slopey, so it's fairly linear. So I used the word earlier, I said we can model this. What I want to get into for right now, we're going to stay here for a few weeks actually, is the idea of mathematical modeling. This is one of the most important ways to use mathematics in the world. I want to give you a brief introduction of this today, and then we're going to let the math do it for us. Mathematical modeling. This is not what you might think it sounds like, Tyra Banks with equations. Modeling simply means using equations to describe data. Using equations, using formulas, however you want to, using math. So, when I hear you guys saying things like, it's doing this, it's about 1 million per year, you're already on the way. You're already on that way. Ashley's giving me the slope. Chrissy's giving me a cubic model, which is pretty slick actually. If you do this, you're making it cubic, which is cool. I like them. Later on, maybe on your next exam, we'll look at Usain Bolt and his world record 2009 100-meter sprint time, and his data is modeled almost perfectly with Chrissy's cubic model. It's interesting because I wanted it to be linear and I wanted it to be quadratic, and it didn't work with either of those. And I'm like, well, let's try something else. And it works beautifully with the cubic. And then I think I can understand why when you analyze how 100-meter sprinters sprint. So it's looking at something that you would never ever think about applying math to, and seeing if math can help you actually answer questions about it. So, and that's why I like this data, because this data, although it's a little bit dated, we're going to bring it into the 2014 here momentarily. It's a little dated, but I love the pattern in the data. And that's what statisticians do so often, is they look at patterns in data. I did this for the past 2 years as I served on negotiations at COCC, looking at the pattern of data, not just at COCC, but at 16 other community colleges across the state, and seeing if there were patterns that were consistent or if there were patterns that weren't consistent. And what tools did I use? Some of the very tools we're going to be talking about in this class. So let's talk back about these guys right here. If we agree that there's a trend